make an edit of this.
So started. Okay. Hello, my name is Aziz. Today I'll be training two other research assistants how to navigate SAS and then eventually use it to analyze data. So generally, you would always begin by, you'll have three files, SAS files, and one is called data. The next would be format, and then last would be analysis. And you would want to start by renaming them with today's date, and then as you work in SAS, each day you'll want to save as the new day's date so that you don't lose your previous work. I'll go ahead and do that. Okay. Once you're ready to begin, you can start by double-clicking the data tab or the data file. You want to open these individually. I would not try to open them all at once. So you could go ahead and click on the first one. Oh, man. Okay, then once the first file opens, you can go ahead and continue to open the other two one at a time. Okay. Once you have the three files open, you could go ahead and maximize SAS, and you'll notice that there's also two other tabs. There's an output and there's a log tab. So the log, usually you can organize it by making it at the top here, and then
can you use this space for the log? That can give you more.
Oh, the whole thing?
No, so the
Oh. Okay, I see. All right, so you can put the log on the right side, then you can organize the data, format, and analysis, each about a third of the screen. And this is basically just for organization purposes. We'll get into it in more detail later, but you'll want to look at the log pretty frequently. And with these tabs going between them, it makes it pretty easy to minimize and maximize between them. So the first step in using SAS is opening the data tab. And at the top, you'll see that we have multiple libraries, and then we also have format libraries here. So to what we call run them, which is basically running the codes and processing them, you will highlight all of the libraries. You could highlight it like you regularly would in like any other program, but also SAS allows you to, if you go just to the left of the line, it turns into like an arrow instead of the other cursor. And then if you hold down, you could just drag down and it'll highlight. It's just a little bit easier, but either way, it's fine. And then at the top of SAS, there's multiple icons. The running man icon, which says submit, is what you click to run whenever you've highlighted. So if we go ahead and click run, you'll see it doesn't really seem like anything happened. But if you go to the log, you'll see that the codes were run. So essentially what that step is doing is telling SAS, it's basically uploading these libraries to SAS. So as you can see, it has the file location where that would be located on the computer. And then it basically loads these libraries into SAS with all the data sets. So we also have this Explorer tab on the left. If you go to libraries, then you can see all the imported libraries here. So these are basically the data sets that we have on the computer. And then if we want to work with any of these data sets, we're able to. But without running them first, you wouldn't have access to these. And if you tried to do any type of analysis, it wouldn't know what data sets you're referring to. And then to navigate the Explorer, you always want to click on it first because the icons will change depending on whether you're in here. You'll see these icons appear. And if you click the Explorer, they change. So you make sure you're in the Explorer, and then this is the back button. You can go back if you need to. So after you run all the libraries, the second most important step is to run all the formats. So again, I'll explain this in more detail later, but basically the formats are basically just ways to convert maybe like a numerical type of code into words, basically. So as you can see briefly just right here, for example, number 1 in a data set could code for this set of words, and then so on and so forth. So you'll want to run every single thing in here. So a shortcut to do that is by just putting the cursor in here and clicking run, and that would run everything. You could also do Control A, and that would highlight everything, or highlight it however you want. But I usually just put the cursor in and then hit run. Then if you go to the log, again, you'll see that it's run. So the reason for checking the log is because it will tell you whether whatever you ran was successful or unsuccessful. So usually if you see blue, for the most part, it's pretty good, or whatever you did was successful. If you see red or maybe green sometimes, there's usually an error. And the good thing about the log is if there is an error, it will tell you basically exactly what went wrong and how you can go about correcting it. So this is when we ran the library names. You could see it says like each library was successfully assigned. So the next step would be to go back to the data tab. And then once you do those 2 steps, you're ready to start working on whatever you need to. So if you're just getting started in SAS, a lot of times you'll be working a lot with Excel. So let's see. For example, if you're using infant growth data or mother's smoking data or whatever it may be, a lot of times you'll compile and clean that data in Excel. So it's good. SAS is good with working between Excel and SAS. Okay, so this is a sample data set that's just random stuff. These names are honestly just random that I just made up. So this is an example of it's something that you might want to import in SAS for later analysis. So, example, you would always usually have the ID of whatever patients you want to look at. And then this is an example of a variable you might want to look at. So, for example, quit success, whether someone successfully quit smoking or not. And you'll see this a lot, the use of binary data in SAS. We use ones and zeros. We could use like ones and twos, whatever you like, to indicate yes or no. And then, as you may notice, you want to try to minimize the use of spaces in SAS because it could just get pretty confusing. So you want to try to not use spaces when not necessary for the variables that you care about. So, for example, these in blue are for a dependence score on cigarette smoking and nicotine. So basically these numbers all add up to this final dependence score, and we aren't going to use these variables, so it's fine. And then the dependence, that we do want to look at this for now, and then this is weight, height, and then height in inches. So we'll go ahead and import this into SAS. And to do so, you can use this import code that I have here. Okay, so for in SAS, a lot of times, depending on what you'd like to do, there will be certain codes that could be pretty complex, but for the most part, they're pretty straightforward if you know the basics. And if not, you can always use SAS book, or you can Google search, or use other resources or other student SAS files to either deduce or figure out the specific code you need to use and how to use it. So for example, this is an import code. I actually believe that I learned how to do this from Google search, and it was pretty straightforward. So to go over this, basically this is a proc import. So for almost all the procedures in SAS, it's abbreviated as proc, saying that you want to do a procedure. And then after that, it usually says what procedure that is. So in this case, it's importing Excel file into SAS. So that's proc import. Out equals, this is stating that whatever you imported, you want it to come out as this data file name. And then as far as the data file, so whatever you want the data file to be named would be here. So in this case, we'll just call it training data set. And then there's this, it says post p0 dot. So if you wanted to save to a folder in SAS and be permanently saved, you want to specify the folder, which again, if you go back to Explorer, Libraries, these are all the different folders. You can save whatever you want to it. If you don't want to save it and you just want to use it like temporarily, or if you're, for example, modifying an existing data set that you don't want to make a permanent change in that existing data set, you could take off the folder name, and then it will save to what we call the work folder. And this work folder does not save at all, and each time you exit SAS, it'll delete what's ever in here. So that may make more sense as we go along. Anyways, here's the rest of the code, data file, and then we specify where the data file is, which I can do now. So you could just go to the top here and copy this directly in. And then you'll want to copy the file name as well. And then in SAS, you want to use semicolons for almost after most of the lines. You'll want to have a semicolon. If not, you won't know where to stop reading whatever line you were writing. However, it depends per code where you should have semicolons, but I guess that will come with practice. And then after every code, you put run semicolon. That knows that it's the end of your code. So if we highlight all of this, again, since there's no folder specified, it should export or import into the work folder, which we're in right now, right here. So highlight and run. And as you can see, it didn't pop up, so there was some type of error. If we go to the log, we can see exactly what happened. So here it says there's an error. It either does not exist or it's already open. So let's see. Actually, I think I didn't specify the right location. So if I go back and fix that, okay, that's sure. Okay, now you can see that the data set's right here. We open it, this is the same thing that I had in Excel. So imported successfully. But as you can see, that's a pretty good example of the use of the log. So I thought that I ran the code successfully, but I typed the file destination incorrect, and I looked at the log and was able to figure that out. And then as you can see, the second time with the correct file name, it says that it was successfully created. And then that's why it popped up here. So, let's see. The next thing that we could do would be manipulating this data set. So a lot of times you might have very, very large data sets, whereas you're only interested in a few different variables. So in that case, it's very helpful to reduce your data set to just the variables you need, just so that it's easier to navigate and it's just much easier to work with. So we could go ahead and do that. If we look at this data set, as I mentioned before, since these are just adding up to the dependence score, I'm really not interested in any of these variables. And then I'm not really interested in centimeters for the height, so we could take that out as well. So one way to do that is, so we could start off by creating a code. We could say data, and this is just creating a data set. And then if you type the name, that would be what the data set, you create a data set will be named. So we could call it training data set 2. And we'll put a semicolon. Then if you say set, this is basically telling SAS where you want to create the data set from. So in this case, it would be the previous data set that we just imported. And semicolon. And then if you put run again, that tells it to run it. However, in this case, as I just mentioned, I am only interested in a few of those variables. So before the semicolon and the set line, I could do parentheses keep, equals, and then I could type just the variables that I want to keep. So go back, we want to keep mother ID. We want to keep quit success, yes or no. All right, so now we have all the variables typed out that we want to keep, and end it with the parentheses, and then this would essentially, again, going over the code. So we said data, then we said the new file name of the file of the data set that we're about to create. So data set 2, we called it set, and then this tells it what data set that we're modifying, which is this one. And then the keep statement is just saying what variables we want to keep. So for example, sometimes I could even show you. Let's see. For example, this data set, there's a bunch of variables here, or even this one, I don't know. Just sometimes, for example, even this data set, there's a lot of variables here that you may only want to use a few. So we're just going to cut it down. So if we run that code, it will then should go to the work folder, two, and as you can see, now we just have what we want to work with. And something else that's pretty useful is the merge function, and that's basically to combine two data sets. Before you're able to merge, though, you'll want to sort, which I do like this. So right now, this data set, if we're looking at the mother ID, it's not in order of, say, alphabetical order. Maybe we want it to be in alphabetical order so that we can merge by the rows. So for example, if we have this how it is, and if we have these same patients in a different order, and we want to merge those two data files, it won't know exactly where to merge the rows. And it might combine data that shouldn't be combined for the same patient. However, if we merge it by, or if we sort it by alphabetical order, for example, then both data sets are consistent, and then once it merges, everything will combine how it should. So to sort, it's another pretty simple code. So you would say proc again, so it's procedure that you're doing. This time we're sorting, and then we do data equals, and then the data set that we want to sort. Training data set, then we do semicolon, and then you say by, and that's telling it what variable you want to sort by. So whether you want to sort it by the mother ID, maybe you want to sort it by weight, by height, etc. But I'd say majority of the time you'll sort by the ID, or in this case by the name. So and then run again. So we can run this, and then should sort. So now it's in alphabetical order. So then basically, if we had another data set that had, for example, their age, we'd sort that by mother ID, and then we could do another code that's just proc merge, and then we would put the two data set names, run it, and then it would combine the data sets. Okay, the next thing that you generally would want to do with your data is to start categorizing the data that you have from that you originally had in Excel or whatever you were working in. So for example, in Excel, we had the quit success, YN, and then for each person, it was binary data, ones and zeros. In the dependents, we had scores ranging from 0 to 8. However, they're just numbers as of right now, and they might not make sense from one person to the next. So to create words out of that and make it understandable and consistent understanding and meaning, we use a format tab. So essentially, we're going to create a code that tells SAS whenever you see a 1 for this variable, it means yes. Whenever you see a 0, it means no. And then we can also do the same for dependents. So we could say any score from 0 to 5 is low dependence, any score from 5 to 8 is high dependence, and so on. You can do that with almost any numerical variable. You could do that for weight and say heavy weight or normal weight or whatever. So to do that, you'll probably want to have your data set open, and then you can go to the Format tab here. So we'll just create a code as you see for basically the rest of these. And usually I just copy the last one and paste it right below. And then modify this however I want it. So I'll just paste it twice since we're going to do 2. So okay, so we'll begin by just copying these variables into the format, and you could basically name them whatever you want or keep it the same. For right now, we could just keep it the same. So copy this, and that's what this will be called. And then since we only have zeros and 1 here, zeros and 1s, this will only need 2 rows. Then for the first one, we'll call that someone who successfully quit smoking. And then for 2, we could call that someone who didn't quit. Did not quit. And for the next variable, we had dependents. And then it's honestly up to you how many different categories you want to make it. You can have it, maybe you could have low, medium, high dependence. You could have low, high, whatever variable you're working on. It's really up to you, whatever you want to do. For this, we'll just probably do 2 groups. We'll say low dependence and high. So anytime you update the format, you'll want to run the entire thing again. You do that, and then check the log. You can see that it said quit success, yes or no has been output, and dependence has been output. So those are the 2 new formats we just made. So that's good. So now that we did that, we need to tell SAS how to code these for our data set, because our data set is still in numbers as of right now. So we can go ahead and close this for now. for the most part, you're unable to modify a data set while it's open. So we need to close that. And again, we'll do the same type of data coding that we did here. So we'll say data, and then what we want the new file name to be called. If you want it to be this, if you want to modify the previous set, you could put the same name. If you want to make a new one, you can make a new name. And then set, this is a data set that we're modifying. So that would be this data set, training data set 2. So basically having these two names the same is going to modify this original set instead of creating a new one. We actually could create a new one, so we'll make this a new name, make it data set 3, semicolon. Then one pretty cool thing that you could do in SAS is you can create nodes for yourself anywhere. Basically, those would be strings of code that aren't read in between a code. So you could do that by doing the / and then the asterisk, and then you'll see the green. Then you could type whatever you'd like, a note to yourself or whatever you want. So in this instance, we're going to be categorizing for dependence, well, actually for quit success. Then you'll end it with more asterisks and / again. And then when you begin typing again, it won't be green anymore. So that's how you know that the note is over. So then you could do an if statement, which is basically saying you type if, and then you want to refer to your data set. So we're basically going to create a statement that says if this variable quit success yes or no is equal to 1, then in the format choose that's equal to successfully quit. And then likewise we'll say anywhere else if this variable is equal to 0, then in the format that would be equal to number 2 here, did not quit. So basically the statement just looks like this. We'll say if this variable yes or no is equal to 1, then this format, which is the same name, quit success YN equals 1, semicolon. So then for any other else, you would say else if, and then you would repeat that if you have more. So then we would say else if, and you could usually just copy this and then modify it. Then else if quit success yes or no equals 2, then the quit success yes or no in the format equals 2. I'm sorry, this should be actually 0, because this first part is referring to your data set. So if it equals 0 in the data set, then the quit success yes or no in the format is equal to 2. So I'll actually make it a little bit easier and I'll switch this to 2cat for 2 categories, and then we'll do the same thing for dependence. We run it, and then you can see I changed the name here. So it's a little less confusing. So if it equals 0, then in the format it should equal 2. which corresponds with someone who did not quit. Then the last part you'd want to do is copy the name of the format. When you say format, then the name once, and then again with a period after and semicolon. And that's basically it. So then you could run it, but we also want to do the same exact thing for dependents. So you could even copy this and then quickly modify it, doing the same exact thing that we just did. So here we're going to modify for dependents. And then, so we're going to say if the dependence score in the data set is between 0 and, let's say, 4, then that corresponds in the format with low dependence. So we could actually say less than or equal to 4. So say if dependence, and then you could just do the less than symbol, and then next to the equals means less than or equals to. And then we'll say less than or equal to 4. Then in the format, the dependence to categories equals 1. So let's see if that's right. So 1 is low, so yep. And then we'll repeat that. So then in this case, if dependence is greater than 4, then the dependence to get two categories would equal 2. And then again, we'll just paste that here, paste it again here, and then that's it. So essentially, again, we're just it's gonna create another data set with these same variables, but it's gonna create two additional variables that correspond with this formatting. And every time you see a 1 here, it will show quit. Every time it shows 0 here, so did not quit, and so on. So let's run that and see if everything went good. And also, again, we're creating a new data set called training data set 3, and we're modifying we're creating that data set from data set 2. So you highlight and run, and as you can see, it created a new data set here. But always check the log regardless, because sometimes it may even create the data set, but there's an error, and you would never know unless you check the log. So it's good. There was 10 observations and 7 variables. So if we look at it, you can see here's the 2 variables from the format that correspond perfectly. So that's good. So one more thing about the log is you can see it says that the data set has 10 observations and 7 variables. So of course variables are referring to the columns at the top, for example, mother ID, quit success, and so on. And the observations refers to the rows. So that's just something to keep in mind, depending on whatever you're working on. It's usually pretty important to keep an eye on these numbers. Okay, this is the end of part 1 of the SAS training. So basically we went over navigation of the data tab and the format, and then in the next part we'll go more into analysis and statistics.